department with the School of Science. My colleagues and I have been working really hard for the last year or two to completely revamp the biology experience. So specifically, we're adding in these independent research experiences within our classes. The big change we've made in ecology is to integrate this question around leaf litter decomposition. And the students can pick their own treatments with which to test whether or not we can speed up or slow down decomposition under different types of environmental conditions. This is one of our groups that presented this last semester and was one of our top groups from that class. And they decided to explore the impact of adding pharmaceuticals to this leaf litter to see if that could impact decomposition rates. But without giving too much away, I'll let them introduce themselves and then tell you all about their project.
Good afternoon. My name is Kayla. This is Zebbian and Ansley. Our group had also two other lab partners that were unable to be with us today. And for our presentation, we decided to investigate the effects of pharmaceuticals on aquatic decomposition. Basically, decomposition is essentially the breakdown of organic substances into smaller, simpler matter. And decomposition is important because it's part of the nutrient cycle and recycles organic material back into the environment. And aquatic and terrestrial decomposition consists of different factors but are equally as important to the environment. Shredders, otherwise known as invertebrates, are also important to help speed up the decomposition rate as well as oxidation. And human influence can affect aquatic decomposition in negative ways, particularly through the excretion of pharmaceuticals that ultimately end up in waterways and drinking water. For example, traces of drugs found in human waste can enter our environment through septic systems and improper disposal of trash. Eventually, trace amounts of unabsorbed pharmaceuticals are found in drinking water and other aquatic environments. And this can impact aquatic organisms and then in turn impact aquatic decomposition. Another example of human influence on aquatic decomposition is a study done by Neil and Moore. And they found that moderately lethal amounts of pharmaceuticals, such as naproxen, negatively impacted fighting behavior in adult crayfish. And when shredders are impacted by the influence of pharmaceuticals, decomposition is also impacted. And with that said, our hypothesis for our experiment is that leaf bags that contain pharmaceuticals will have lower vertebrate diversity in decomposition.
So during our experiment, we followed basic steps: pharmaceutical prep, leaf bag prep, leaf bag deployment, leaf bag retrieval, and then leaf bag processing. For our experiment, we measured the impact of pharmaceuticals on aquatic decomposition rates with 4 experimental bags that were soaked in ibuprofen and then 4 control bags. The pharmaceutical that we used was over-the-counter ibuprofen, which was 200 milligrams. We crushed up 4 200-milligram tablets in place, which equaled out to 800 milligrams, and we placed those into 2 liters of water. And we had 4 5-liter buckets, and we placed 2 liters of water with that ibuprofen in it for the bags to soak for about 30 minutes. For our leaf bag preparation, the bags that we used were like the mesh bag, and we use those so once you put them in water, it still has ways for things to come in and out, such as shredders. We placed 10 grams of leaves inside of those mesh bags, and that was each bag had 10 grams of leaves inside. We used paracord to tie them off and close them so that no leaves would escape the bags. For our deployment, we used Haynes Branch Creek, which is located in Jacksonville, right behind Cooter Browns. We placed our experimental bags downstream so they wouldn't be affected. If we placed them upstream, then our control bags would have been affected. So we placed our control bags upstream and then our experimental bags downstream. For our retrieval, we left our bags out for 28 days. And during that time frame, we did have a lot of rain floods, so we did do one experimental bag. For our leaf bag processing, we took each individual bag and processed the leaves from each bag. So we had 3 experimentals and 4 controls. With the processing, you would take the bags out, rinse them out really good a couple of times, and then you would place them in the seal to get rid of any debris, excess sediment, and the invertebrates which were stored for later processing. Now our invertebrate processing. Any snails or crawfish that we found in our bags, we did release them out into the environment again. For our processing, we took the invertebrates and placed them in ethanol so we can process them after we did the leaf. So we took all of our experimental invertebrates and placed them in a cup of ethanol. So at this point, we would take the cup of ethanol, pour them out into a quadrant, and we would randomly pick a quadrant for us to look at those invertebrates in there, and then we multiply by 4 so we could get that data. And we also did that with our control.
So after all of the processing, we had to run some analyses, and we wanted to find the total leaf mass lost over the 28 days. So we had the final leaf mass minus the initial over the initial times 100%. And then we divided that by 28 days to find the decomposition rate per day for the control and for the experimental separately. And then we ran standard deviation, means, and a two-tailed t-test. So here is our decomposition rate graph comparing the treatment groups and the control groups. As you can see, the treatment is 1.6% and the control is 1.53%. And after we ran our t-test, we found our p-value to be 0.64, which is a very high p-value. So that p-value told us that our control and treatment bag decomposition rates were not significantly different. And we did lose one experimental treatment bag, as said before, due to just environmental error because there's a lot of rain during the 28 days that our bags were released. So after that processing for the invertebrate, we counted how many invertebrate were in one of the quadrants and times it by 4. And we had found that there's a little bit more diversity in the control groups than the treatment groups. And there was only one duplicate because of the jars that we placed them in, so we couldn't run any statistics on our invertebrate. So our original hypothesis was to say that if there were more shredders present in the leaf bags, then the decomposition rate would be higher and there would be more decomposition every day versus if there were not as many shredders present, because we thought pharmaceuticals would maybe deter the shredders from entering the bags and shredding the leaves that were in it. But because of the results from the t-test and the comparison of decomposition rates, we concluded that where there was little to no difference in those decomposition rates, so maybe that there wasn't as big of a deterring from the insects and invertebrate. So our gaps of knowledge weren't really reached, but more did open. So maybe we could try different pharmaceutical like antibiotics, and maybe that would be different decomposition rates. And in conclusion, we failed to reject our null hypothesis, and because of the limited amount of time of 28 days, we thought we weren't really able to conclude that the pharmaceuticals present truly impacted the aquatic decomposition in shredders. And we just want to thank Dr. Wofford for her guidance and advisement during the semester. We really enjoyed the ecology lab. We really loved it. We got really close, and we would also like to thank Dr. TJ for helping us for data processing, and Dr. Rayburn for helping us transport materials, and then our teaching assistant, Andy, for taking our pictures. And that's it. Do you have any questions?
What led you to going and choosing ibuprofen for your pharmaceutical?
So ibuprofen is just like a common over-the-counter pharmaceutical, And we thought that that might be a pharmaceutical that would be excreted in the waterways a lot more than versus others in this area.
I have another question.
Yeah.
Do you think prescription ibuprofen might have different results, or would it be the same?
So normally when they prescribe, they're prescribing you 800 milligrams. So with the ibuprofen, we equaled it out to 800 milligrams, so it'll equal about the same amount.
Could you say more about your design for using quadrants and then multiplied by 4? Was that kind of a limited resource model, or was there another reason for that? Why did you choose that as your method?
I think we chose that as our method because it was more efficient with time. Because after we put all the invertebrates from each bag into the jar for the 4 bags from experimental and 4 bags from controls, we came back later for the next lab meeting and put everything in the jar into like a quadrant tray that had lines, and we mixed it around evenly, trying to disperse it as evenly as possible to give a good representation of the 4 bags. I think it was just for time's sake.
All right, let's thank our speakers again.